This example is again asking us to use 6 subintervals to estimate the area between the curve and the x-axis for this given equation on this specific x interval right here. And they want us to do it as a left-hand sum, a right-hand sum, a midpoint sum, an upper sum, and a lower sum. So they want all of them. These are all really housed under one category of problem. This is a Riemann sums. This specific problem, I'm going to go ahead and do, I did a left-hand sum video earlier you might have seen. I'm now going to focus in on the right-hand sum for this specific problem. So for this video, we're going to talk about how to determine the right-hand sum. 2/3 of this is going to look exactly the same as any of the other videos. You start off with this, and you go ahead and draw out your number line. So label your number line based upon your x intervals. So we've got 1 and 3 are the endpoints. Then we mark off each subinterval based upon a delta x. How much change in x? How much do we go over between each next endpoint? So to find your delta x, that's always max minus min divided by the number of subintervals. So in this model, the max is 3, the min is 1, and then the number of subintervals was given to us as 6. So out of there, we get 2 over 6, which gets us 1/3. So our delta x is 1/3. We take that delta x, and what that allows us to do is now mark off this number line every interval that we're concerned with. So starting at 1, I move over 1/3. So adding 1/3 to 1 is going to get me 4/3. Moving over 1 from there would get me 5/3. Moving over 1 from there would get me 6/3, which is also known as 2. Moving over from there would get me 7/3. Moving over a third from that would get me 8/3. And then moving over one more third would get me 9/3, which is known as 3. I then come back and I just label my little subintervals. So this is A1, A2, A3, A4, A5, A6. It reminds me what I'm trying to calculate, and it also confirms that I have the 6 subintervals that I'm being asked to find. The rest of this process I just kind of call the assembly line process. You're just going to come down here and we're going to find area formulas for each of these 6 subintervals. Oops, not A5. This would be A4, A5, and then A6. We are calculating these out using the area of a rectangle. So the area of a rectangle formula is base times height. The base on all of these rectangles is going to be the same. It's the distance between our x values here. It's our delta x. The distance between all of these little regions is 1/3. So we're going to call it delta x for right now, but we know that that delta x is the same delta x on all of these. Now to find the function value, the height of our rectangles, that will be the y value off of that space. And so I go f of, f of, f of, f of, f of. And so to know what value, what y value to get out, that's where these left-hand, right-hand, midpoint, upper, and lower sums come in. This is the only part of the process that changes from these different types of problems. We need to plug in our evaluation points to get the heights that we need. Those are going to be the x values off of our interval. So this time again, we are talking about a right-hand sum specifically. So working my way through this, I start at A1. On A1, I've got a choice. I've got a left endpoint and a right endpoint. We want the right endpoint, so we would plug in 4/3. On A2, you play the same game. You've got a left endpoint and a right endpoint. You want the right endpoint, so you would plug in 5/3. On A3, same game. Left endpoint, right endpoint. You want the right endpoint. That would be 2. On A4, we're looking at left endpoint, right endpoint. We want the right endpoint. That would be 7/3. Then again, left endpoint, right endpoint on A5. Looking at the right endpoint, so 8/3. And then our final interval, A6, left endpoint, right endpoint. And we want the right endpoint, so we plug in 3. So from there, we continue down our whole process, our assembly line process, and start plugging in real values for everything. So the delta x is the same on all of them. It's the gap between our intervals. So in this one, all of our delta x's are going to be 1/3, 1/3, 1/3, 1/3, 1/3. Now, when we come back, we need to find those height values. So you find those heights by plugging those x values, those evaluation points, back into the original function. So back into the original equation. So that might require a calculator on your part. You just plug and chug everywhere you see an x in that equation, you're going to plug in your evaluation point of 4/3. So plugging in 4/3 into that equation would get us 52 over 27. Plugging in 5/3 to that equation is going to get us 59 over 27. Plugging 2 into that equation is going to get us out, what do we get, 2. Then plugging 7/3 into that equation, we get out 43 over 27. Plugging 8/3 into our equation, we get 32 over 27. And then finally plugging in 3 into that equation, we get out 1. And so now what we need to do is just come back and do that math. So find out what those specific values are. So 1/3 times 52 over 27 is going to get us 52 over 81. Multiplying 1/3 by 59 over 27 is going to get us 59 over 81. 2 times 1/3 is going to get us 2/3. 43 over 27 times 1/3 is going to get us 43 over 81. Doing it again, 1/3 times 32 over 27 gets us 32 over 81, and then 1/3 times 1 gets us 1. So that's the area of each of those individual rectangles. And then to get our total estimate for all 6 of these subintervals, you're just going to add all of those up. So now you're just going to take and pop into your calculator all of those values. You'll add them up. And so in this scenario, when we add all of those up, we would get out 89 over 27. And so that's our final answer for this. That would be our right-hand sum here. So again, the process on this looks identical from each of these different sums. The only difference comes when you're finding that height right there and when you choose your evaluation point. That will be the piece that changes from problem to problem. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.